MEM School of Engineering in Department of Mechatronics Engineering, online class 4, subject Mechatronics, Unit 1, Chapter 4, myself Saravanan, Assistant Professor, Mechatronics. So this is the course objective and outcome of Mechatronics, the syllabus, textbooks, and Unit 1. In Unit 1, we are going to see about chapter number 4. In chapter, we are going to discuss about sensors and transducers. Okay, last class we saw what are the types of sensors available in the manufacturing process. Okay, so today we are going to we are going to see about some of sensors. Okay, that is potentiometers, Lbdt, tactile sensor, force sensor, and incremental encoder. First, potentiometer. The potentiometer can be of linear or angular type. It works on a principle of conversion of mechanical displacement into an electrical signal. The sensor has a resistive element and a sliding contact wiper. The slider moves along this conductive body, acting as a movable electric contact. Okay, so the object of whose displacement is to be measured is connected to the slider by using a rotating shaft, that is for angular displacement, a moving rod for linear displacement. Okay, a capable of that is kept stretched during operation. The resistive element is a wire wounded track or a conductive plastic. Okay, so during the sensing operation, a voltage Vs is applied across the resistive element. Okay, a voltage divider circuit is formed when slider comes into contact with the wire. So the output voltage Va is measured. So the output voltage is proportional to the displacement of the slider over the wire. So then the output parameter displacement is calibrated against the output voltage Va. Okay, using Va we can calculate the output voltage. Okay, in control injection modeling machines, so woodworking machine potentiometer, that is electric circuit. So this is the uh, diagram for potentiometer. So this is the direction of rotation. This is the direction of linear motion. So string cable, coil spring, potentiometer, so terminals, so resistive step. So as well as this is the basic equivalent circuit for this one. That is resistance variation. So for displacement process, for variations of resistance, we can calculate the output voltage. Using output voltage, we can calculate the displacement. Okay, that is potentiometer sensors. Okay, here VA is equal to IA, that is current into resistor. But generally, we know that I is equal to V divided by R. So here we have two types of resistance, that is RA and RB. So we need to use RA and RB. Okay, so then we can calculate as VA is equal to V source. So that means this resistance changes in the source voltage. So what is the voltage, like that we need to know. Okay, so that is resistance multiply with the total resistance multiply with the source voltage, that is Vs. So that is V. Okay, so V is equal to like this. So VA so this equation is VA with respect to the L, that is length of the resistor. This is the length of the resistor dependent. So for changing this R to L, we need to use R is equal to rho L divided by EA formula. So rho is a electrical resistivity. So used in this equation means the rho will be deleted. Okay, the rho will be removed. Okay, so A is the area of cross section. So A also removed from this equation. So only L will be available. That is L is different, LA and LB. Okay, using this formula we can calculate the output voltage with respect to the resistance. Okay. So potentiometer, where it is used. Okay. So that is application of potentiometer. So these are typically used on machine tool controls elevators, liquid level assemblies, forklift trucks, automobile throttle control. So like that we are using potentiometer. In manufacturing, printing, spraying, robotics, so like that they are used. These are also used in computer controlled monitoring of sports equipment. Computer controlled monitoring of sports equipment, they are used potentiometers. This one is linear variable differential transformer, that is generally called LVDT. So LVDT is a primary transducer used for measurement of linear displacement. Measurement of linear displacement with an input range of plus or minus 2 to plus or minus 400 millimeter in general. It has non-linearity error plus or minus 0.25% of full range. The construction of a LBDT sensor, it has three coils symmetrically spaced along an insulated tube. The center coil is primary coil and the other two coils are secondary coil. So secondary coils are connected in series in such a way that the outputs oppose each other. A magnetic core attached to the element of which displacement is to be monitored is placed inside the insulated tube. Due to an alternating voltage input to the primary coil, alternating electromagnetic force are generated in secondary coils. So when the magnetic core is centrally placed with its half portion in each of the secondary coil regions, so then the resultant voltage is 0. Okay, this is the basic concept. So this is a linear movement, that is a core, that is motion of between the cores. Okay, here we have fully explained. That is primary coil uh, normally connected with the flux with secondary coils, but when armature comes, so this is the affected zone. Okay, this iron core comes means there is no flux transfer between the primary to secondary. Okay, so the voltage level will be varying. Same as if we move the rod, so some of the electric fields move to the secondary coils, so the voltage will be increasing. Using this we can calculate the displacement